Good afternoon. This is Engineer Iyad Al Khresat from Arab Potash Company in Jordan. I will talk about the modification of anti-caking addition process at Arab Potash Company, APC. At the beginning, I will talk about what does APC produce. As most of you know, APC produces potash. The annual amount is 2.35 million tons of potash per year. Also, you know that more than 90% of potash produced in the world is used for fertilizers, either directly or in industrial processes to manufacture compound fertilizers. Potash term is commonly used to describe potassium-containing salts that are used as fertilizer. Any salt that contains the element potassium, the potassium element, and used as fertilizer is called. Most of potash is derived from the potassium chloride, KCl, as the case in ABC. KCl is also known as muriate of potash, MOP. ABC produces potash in 4 grades. As you can see, we have 4 grades of potash: standard, fine, granular, and industrial. Now I will talk a little bit about the caking problem. Potash, as most solid mineral fertilizers, displays a natural tendency to form lumps or to cake during storage and transportation. Especially if you know that potash is a hygroscopic material that easily absorbs and retains moisture from the surrounding. So, what we did to mitigate the caking problem. In ABC, the caking problem is being resolved through surface treatment via the addition of anti-caking material. The caking stages in potash particles is similar to the one shown in this picture. We start with the free-flowing particles, then capillary addition start due to ions and saturated solutions migration. This will form salt bridge. With time, salt bridge become thicker and longer, and result finally in caked product. Now we'll talk about anti-caking material used in APC. It has a commercial name its commercial name is Floderam 601. This material is available in liquid and solid forms. This material is a tailor-made coating agent that keeps potash free-flowing and prevents caking, dusting, and moisture uptake. This material is a mixture of compounds based on fatty amine derivatives and fatty acids. 2 kinds of compounds. The anti-caking effect of the material come from one kind, which is the fatty amines. The anti-caking effect is based on the hydrophobic action displayed by the fatty amines. To make things simpler for you, this is the 2 compounds that this material consists of. We have the first kind of compound is fatty amines, 30%. It's the active material, and we have 70% fatty acid. It acts as a supporting material. You can see the general formula for these 2 compounds. The exact formula is, we don't know the exact formula. It's kind of know-how for the company that provide us with this material. Now I will talk about hazards of these materials. As you can see in the pictograms below in this slide, this material has health hazards. It may cause damage to organs through prolonged or repeated exposure. Also, it's a corrosive material. This material is very toxic to aquatic life. Moreover, Another hazard is resulted from the fact that this material is added to the product dispatch, which has a temperature of more than 85 degrees centigrade. Okay, now I will talk about old addition process. What is the original case? In this old process, we used liquid anti-caking material. As you can see in the pictures, the addition point in the red rectangular was exposed to workers, and the workers involved in the addition process suffered from injuries, from health difficulties. Also, this system had other challenges and problems. As you can see, we divided the problems into 3 categories. The first one is process safety. The system suffered from repeated failures of the control system of the unit. Also, we have problems with product quality in case of granular potash. We have granular potash in ABC has bigger size, so we suffered from inefficient coating for this type of product. And the most important problem was the workers' safety. As I said, many workers suffered from injuries, from the health difficulties. So, what we did, we modified the addition process. We started with the process hazard analysis. A team consisting of engineers and technicians from operation and maintenance departments did the process hazard analysis. This followed by action plan. This action plan, the approach taken in this action plan was in line with the hierarchy of safety control measures. The hierarchy of controls is well known. As you can see, it starts with elimination and ends with PPE. As you go down, the effectiveness decreases. We couldn't start with elimination. We have to do this coating process. So we don't do anything with elimination. We start with substitution. We substitute the liquid anti-caking material with its solid form. The solid form is less hazardous, and the splashing risk and the contact to eye and skin were eliminated. Then we start with engineering controls. We conducted 4 engineering controls. The first one is isolation of the contact location of the anti-caking material with the hot product dispatch. As you can see in the picture, the lower part, the contact point, is completely closed and isolated, and it can't easily accessed by the workers. Second engineering control we did is transferring the location of the manual addition point of the anti-caking material to another floor to be far from the mentioned contact point. As you can see in the picture, it's very far and it's safe. The addition is done manually in APC. So we transfer the location of the manual addition point to be far from the contact point, as you can see. The third engineering control was the erection of new process control system. This control system assists in keeping the addition process at constant rate. It includes several safety controls, alarms, and interlocks. The fourth engineering control we did is a construction of new addition units for granular potash. As I said before, granular potash has larger particle size than other types of potash. So after several lab trials, we decided to add mineral oil to granular potash in order to support the function of anti-caking. In this unit, the solid anti-caking, as you can see, the solid anti-caking material is dissolved in a heated mineral oil and mixed well. The mixture is applied to the product. This modification resulted in improved coating efficiency of granular potash. The 4 engineering controls almost eliminated the hazard and mitigated the problem. But we don't stop. We went to the administrative controls. We conducted several safety awareness sessions. We created the standard operating procedure for the process. We conduct on-job training, periodic inspection for mechanical integrity, first aid measures. We have lists of instructions posted in the area of work. Also, the material safety data sheet for Floodiram 601 was communicated in Arabic and English with the worker. Finally, we recreate a PPE plan. As you know, the PPE is the last line of defense, with proper training for the workers. To conclude what I have said, among the different implemented controls, we have administrative controls, engineering controls, substitution, and PPE. The engineering controls were the most effective with quick and tangible positive impacts. These engineering controls had the major contribution to reduce hazard associated with additional process of the anti-caking material. And overall, the implemented action plan had successful results in terms of worker safety, process safety, operational aspects, and product quality.